Good day and welcome to the Big Bad Tech Channel. I'm your instructor Jim Pytel. This is the Basic Electronics 1 DC Circuit Analysis playlist.
This short lecture is a brief introduction and orientation to the Basic Electronics 1 DC Circuit Analysis playlist, as well as recommendations on how to use its contents to further your educational goals. The Basic Electronics 1 DC Circuit Analysis playlist is a sequentially arranged series of free online lectures designed to support a flipped classroom approach to teaching basic electronics. Flipped classroom approach to instruction uses online lectures to deliver instruction outside the class and activity-based learning and lab exercises inside the class. Students watch lectures at the time and place of their own choosing, at their own pace, and concept engagement and application takes place in the classroom with the guidance of an instructor. Advantages to this instructional approach can be numerous. The online content is flexible, accessible, and can be paused and reviewed to support the learning process. Commute time, travel expense, and textbook expense for students is dramatically reduced and allows students with family and employment obligations to remain enrolled in school. Whether you use this content in your class or independently use this content to brush up on specific skills, supplement or replace a textbook, or just make up for a class you skipped, I hope you find it useful. These online lectures are not passive resources like a traditional face-to-face classroom lecture or a static textbook, but rather they are alternative resources that necessitate the active participation of the student. The lectures present important content and most feature applications of this content in the form of illustrated example problems. If there is a single piece of advice that I can deliver about getting the most out of these lecture series, it is this. Pause the lecture when asked to do so and attempt to solve the problem by yourself using the previously discussed skills. If you're struggling, the illustrated example problem will guide you to the correct solution. Long story short, you are going to drown if you don't kick your legs. This is to suggest that the responsibility of showing up to lab prepared is placed squarely on your shoulders. Content delivery is staged in that basic concepts are progressively built upon and each next topic increases in complexity. Watch the material as many times as you want, wherever and whenever you want. If you need more time, feel free to pause the lecture to take notes or rewind to review material you may have missed. You can't do that in a traditional lecture, but here at the Big Bad Tech Channel, you are the one that is in charge of your education. Historically, most students do well and enjoy the flipped classroom approach. However, it takes effort, discipline, and good study skills. The final grades of most of the classes I've taught using this approach can be described as bimodal, in that there is a large number of students that succeed and a small number of students that do not, with very few, if any, students in the middle. My succinct analysis of this historical trend is this: do what your instructor tells you to do. Don't do what your instructor tells you to do. Actively participate in the online lecture and pause it when asked to do so and attempt to solve the illustrated example problem. Pause, rewind, and review the material as needed. Take notes and get involved. Take charge of your education, commit to the task, and succeed. Success will not be easy and there will be setbacks, but you can do this, and these free resources are here to assist you whenever and wherever you need it, as many times as you need them. The Basic Electronics 1 DC Circuit Analysis playlist teaches DC circuit analysis from the perspective of conventional current using algebraic, i.e., non-calculus methods. The order of this playlist represents the sequence in which it is intended to be watched. For those individuals interested in a streamlined intro to electronics, feel free to skip over content you deem unnecessary or unimportant for your particular career field or interest. The more advanced or specialized content can be returned to on an as-needed basis. The playlist can be roughly divided into 9+ units, where each unit might take a week or more to get through if you're on a traditional academic quarter schedule. If you're unusually disciplined, you can binge all day, every day, but that's a recipe for disaster. A pile is best moved a shovel at a time. This playlist is a mountain of material. Unit 0 is a review of prerequisites. As the numerical indicator 0 implies, this suggests that you should already have these prerequisite skills if you are to make any forward progress in this series. One must unconditionally accept that this is not a math class, and I refuse to teach you math. This is an applied math class that discusses basic electrical theory using math skills you should already have. This being said, the Unit 0 topics perform a basic review and inventory of necessary math skills, including engineering prefixes and unit conversion, as well as a general industrial safety orientation. Unit 1 is an introduction to basic electrical concepts, including energy, power, voltage, and current. This material isn't exactly the toughest. However, important conceptual foundations are established in this unit that carry through this playlist and others. Take these foundational topics seriously and put in the effort to understand and differentiate between the terms and concepts employed. Think about it. Draw a picture. Take notes. Voltage is different than current, and it is measured differently. Energy is different than power. I am messianically insistent you understand this. Unit 2 is a collection of online lectures that discuss resistance, the opposition to current flow. This unit also introduces common lab instrumentation and equipment like the ohm meter and the prototyping board. Get into a safe and supportive lab environment and get your hands on this equipment. In the immortal words of Bruce Lee, boards don't punch back. Apply these skills to the real world. Unit 3 discusses Ohm's law and power. Ohm's law is a pivotal concept that ties together the relationship between voltage, current, and resistance, and will be regularly applied throughout this series and others. Expect lots of illustrated example problems. Additionally, this unit introduces the voltmeter, the ammeter, and the DC power supply. Unit 4 discusses series, or inline electrical relationships, and the important properties that govern series electrical circuits. This unit also discusses Kirchhoff's voltage law and a handy shortcut called the voltage divider rule. We'll learn that current through elements in series is the same, and that what goes up must come down. Additionally, this unit covers applications of series circuit properties, including switches and circuit protection devices like fuses and circuit breakers. Unit 5 discusses parallel or side-by-side electrical relationships and the important properties that govern parallel electrical circuits. This unit also discusses Kirchhoff's current law and a handy shortcut called the current divider rule. We'll learn that voltage across elements in parallel is the same and that what goes in must come out. Additionally, this unit covers applications of parallel circuit properties, including power distribution and generator synchronization. Unit 6 covers more complicated circuits that combine elements in both series and parallel. These circuits, appropriately enough, are called series parallel configurations. Fair warning, I teach series parallel circuit analysis way differently than most lectures and textbooks, in that I do not sell you snake oil and magic charms, but rather employ previously acquired basic series and basic parallel properties to series parallel circuits. This cuts down on the stupid busy work and yields correct answers far quicker and more reliably than the false skills and superstitious quackery your expensive textbook may try to sell you. Current through elements in series is the same. Voltage across elements in parallel is the same. What goes up must come down, and what goes in must come out. I might have mentioned that before. Given you've mastered Units 4 and 5, Unit 6 should be easy. If the concepts in Unit 4 and 5 evade you, Unit 6 will straight up crush you. An instructor brimming with hope and enthusiasm might pick you up, dust you off, and tell you it's alright, but I'm not one of those type of instructors. I'm just going to hose you down the drain and tell you to turn back if you are so crushed. Series parallel circuit analysis is a critical test of your comprehension, and you cannot proceed until you slay this beast. Don't worry though. The lectures in Unit 6 feature copious amounts of illustrated example problems, and series parallel circuit analysis is largely taught by doing series parallel circuit analysis. Unit 7 is a collection of various circuit analysis topics for circuits in which elements are neither purely in series nor purely in parallel with one another, and for circuits incorporating multiple voltage or current sources. As important as electronics is, I'll be the first to tell you that not everything taught in a traditional basic electronics course is universal, easy, or even applicable. There's this mistaken idea that unnecessarily complex special use skills like mesh and nodal analysis are somehow still relevant in our modern society. I beg to differ for this very important reason. Most career fields will never, ever, ever make use of these esoteric skills. My preferred approach is to teach circuit analysis topics using skills you should already feel comfortable with applying, namely series parallel circuit analysis in the form of the superposition theorem. The point is, don't haul the whole tool shed around if all you need is a screwdriver. This being said, I do include lectures on both mesh and nodal analysis in this unit, only out of sheer pity for those students whose instructors force them to use these techniques. If your instructor makes you learn mesh and nodal analysis, use these lectures so you can dump the right answers on a quiz or a test and then just forget these techniques as soon as possible. Finally, Unit 8 is a collection of circuit analysis theorems, including Thevenin's theorem and the maximum power transfer theorem. While not necessarily recommended for those desiring a crash course in electricity and electronics, these two theorems are essential for later applications and those enrolled in a complete electronics engineering technician course. These theorems necessitate visualization and copious amounts of practice. Luckily, these lectures incorporate numerous illustrated example problems to test and validate your skills. You'll notice most of these 8 units end with a lab practices and/or a software simulation exercise. These unit add-ons make great self-assessment exercises, as well as recommended lab experiments for instructors choosing to adopt this particular playlist, or for those students attempting self-study. If you're an instructor insane enough to consider adopting this playlist, please check out the instructor's guide. Long story short, yes, it's free, and I'm encouraging you to make aggressive use of this playlist to supplement or replace your textbook or face-to-face lecture. At a minimum, this playlist can also be thought of as a secondary repository of resources for those students seeking review or additional guidance. But wait, there's more. These 9 units do represent, in my professional opinion, the core skill set required by individuals claiming competency in DC circuit analysis. However, represent only words, not sentences that form ideas or applications. It is for this reason the Big Bad Tech channel also includes other lectures and playlists that can be unlocked once a degree of competency is reached using the Basic Electronics 1 DC Circuit Analysis playlist. The idea is to include applications of circuit theory as soon as possible. I mean, really, what's the point of learning electrical theory if you don't get to build cool stuff and occasionally set things on fire? For educational purposes, of course. An example is the Batteries playlist that examines lead-acid batteries using skills obtained in the Unit 4 series circuit analysis. If you've completed Unit 4 and want to take a side trip to Battery Land, be my guest. If you want to continue on to Unit 5 and check out batteries later, that's cool too. The point is, the further you progress through the playlist, you'll have more arrows in your quiver and more targets to hit. Don't go wildly off track, but don't be the person that never ventures into the woods. Electricity and electronics is truly a fascinating subject, and I never tire of learning and applying new concepts. I hope to share this enthusiasm with you by providing a guided tour with plenty of interesting side trips. Let your interest determine your path. Development of the Big Bad Tech channel is ongoing, so be sure to subscribe to the channel to receive the latest news and updates. That's about it for the introduction and orientation to the Basic Electronics 1 DC Circuit Analysis playlist. Before I sign off, I'm encouraging those of you with questions or comments to please contact me via the Big Bad Tech channel. However, I'd like to answer some frequently asked questions up front. The question I'm most frequently asked is, how do I record these lectures? The whiteboard I typically use is Microsoft OneNote. The screen capture software I use is Camtasia, and I record these lectures on a Dell Latitude XG3 laptop. The second of my most frequently asked questions is, can you help me with my homework, lab, or project? No. Unless you're one of my students, you are on your own. It would be conduct unbecoming of an engineer for me to issue professional advice without direct involvement. This content has been developed for edification only. While reasonable care has been exercised with respect to its accuracy, the author, i.e. me, assumes no responsibility for errors, omissions, or suitability for any application or misapplication, i.e. laser guns or stun guns, of its contents. Due to the sheer number of inquiries I've received, please be aware that it is impossible for me to answer personalized requests for additional information, like custom designs, technical advice, troubleshooting advice, or dating advice. Though I cannot acknowledge individual inquiries, I'd be happy to receive any comments, impressions, suggestions, and large monetary donations. Thanks in advance. 3. I noticed an error in your lecture. What is the accepted procedure for correction? Step 1. Check if there's an annotation or a card that indicates there is an error with the correction. Sometimes, however, certain viewers or mobile devices do not show the annotation or card. Step 2. Check the comments. Ordinarily, unless you're the first person to notice the error, someone's already noticed it and have replied with the correction. Step 3. If you are the first person to notice this error, verify the correct answer, and please notify me. I'm not some dim-witted peddler of nonsense, but by no means am I infallible. Long story short, I'm human too, and every once in a while I'm going to dork something up. I'll do my best to issue a correction in as timely a manner as possible. 4. I noticed an inconsequential rounding error, a nitnoid slip-up, or you mispronounced or misspelled a word. What is the accepted procedure for correction? Make a super big deal out of it and post an angry screed on YouTube comment in all caps. Cancel your subscription to the internet. That's the way to solve the problem. By the way, that's sarcasm. The correct response is just to deal with it. 5. Why are you a teacher? Well, it's certainly not for the money. However, I really do enjoy this career, and I feel like I'm making a difference in my community and my country. As hokey as it sounds, I view domestically produced renewable energy and a trained, technically competent workforce as important strategic assets to the United States. I don't mean to sound bleak, but the future holds a world with increasing population and diminishing resources. This oncoming conflict can be won without fighting. Renewable energy is homeland security. If you've got any other questions or comments, again, feel free to contact me via the Big Bad Tech channel. In closing, let me remind you that the material inside the Basic Electronics 1 DC Circuit Analysis playlist is meant to support a hardware lab. The online material at the Big Bad Tech channel cannot, will not, and never makes the claim to replace time in a safe and supportive lab environment. The content of this playlist, at best, represents the minimum understanding necessary to even enter a lab. That being said, imagine how well lab will go if you know what you're doing. Thank you very much for your attention and interest. Remember to tell your lazy lab partner about this resource, and be sure to subscribe to the Big Bad Tech channel. You'll be the first to know when new content is made available.